Assalamualaikum. We are from Group 12 and this video is about titration in food manufacturing. Now I will introduce our team members. Nur Afika binti Muhammad Sukri, Nur Aina Bila binti Syaipulizam, Nur Lydia Emizatul binti Suhaini, Nur Syahira Alia binti Mazlan, and lastly Nur Batrisha Idrina binti Edi Shawal.
This is a table of content. The first one is introduction, the second one is types of titration, the third one is methodology of titration and example of result, the fourth one is application of titration technique in food manufacturing, the fifth one is advantages of titration technique in food manufacturing, conclusion, lastly, references. Introduction. Titration is in which a standard reagent is added to a solution of analyte until the reaction between the two is judged to be complete. The point at which the reaction is complete is called the endpoint, and it is often detected using an indicator or a pH meter. One type of titration commonly used in food manufacturing is acid-base titration.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurija Imzatul Natasha binti Suhaimi with my student ID 2022855224. I will present about the types of titration used in food manufacturing. First and foremost, acid-base titration. In theory, this method involves neutralizing an acidic or basic analyte with a titrant of known concentration, where the endpoint is usually determined by a pH indicator. The final product doesn't need to be completely neutralized because it all depends on the pH range of indicator. Furthermore, it is useful when the product needs to have a precise pH range because if not, it may affect its taste. For example, function of this method is to determine the acidity of fruit juice. Next, reduction, oxidation, titration, or redox. Theoretically, in this type of titration, an oxidizing agent is titrated with a reducing agent or vice versa that involves the electron transfer. It is significant because the way a processed food is oxidized can affect its preservation and shelf life. As an example, measure the amount of vitamin C in orange juice. Other than that, precipitation titration. In theory, this type of titration involves the formation of solid precipitates which are not soluble in water. The endpoint can be determined by several methods, such as by light scattering as the solution becomes cloudy, or by using potentiometer. As an example, precipitation titration can determine the salt content in different food products. Last but not least, complexometric titration. Theoretically, it is a type of volumetric titration that uses the formation of a complex between analyte and titrant to identify the reaction's endpoint. As an example, it is used to determine the content of calcium in dairy products such as milk and cheese.
Here are the methodology of titration technique. Now, let's take a look at this example of the acid-base titration in determining the acetic acid percentage in vinegar. Here's an overview of the procedure conducted in the experiment. A precise volume of vinegar is measured and placed into a flask. A few drops of an indicator such as phenolphthalein are added to the vinegar. In this case, we use phenolphthalein so the indicator will change the colorless solution to the pink solution, signaling the endpoint of the titration. The standard solution, which is sodium hydroxide, is added slowly into the vinegar while we stir the flask. As the sodium hydroxide reacts with the acetic acid in the vinegar, the titration continues until the color of the indicator changes, indicating that all the acetic acid has reacted to the sodium hydroxide. Then, the volume of the sodium hydroxide solution used is in the titration is recorded. Now, we will see the example of result. This table is an example of result from an experiment using a titration method. In this experiment, we use standardized sodium hydroxide to titrate in order to determine the content percent of acetic acid in vinegar. This is how we calculate the percent of acetic acid in vinegar. First, we need to find the mass of acetic acid. Then, the second step, we will use weight over volume times by 100 formula. So, in this experiment, there are 7.92% of acetic acid in vinegar.
Next, I'll be talking about the application of titration technique in food manufacturing. My first point is it can use to determine acid content in food. Acidity is a crucial parameter in many foods, affecting flavor, preservation, and microbial stability. Titration helps in accurately measuring the acid content. For example, in fruit juice production, titration with sodium hydroxide is used to measure citric acid content. This helps manufacturers adjust the recipe for consistent taste and prevent spoilage, ensuring the desired taste and shelf life. Moving on to my second point, it can use to analyze the fats and oils in foods. The quality of fats and oils in food products can be assessed by measuring free fatty acid content. Titration is used to determine the degree of hydrolysis and oxidation in oil. For example, in edible oil production, titration with potassium hydroxide measures free fatty acid, ensuring the oil's quality and shelf life. Last but not least, it can use to analyzing sugar content. The sugar content in food product is crucial for flavor, texture, and fermentation processes. Titration can be used to measure the concentration of sugars, especially reducing sugars. For example, in jam and jelly production, the Lane-Enon method uses titration with copper sulfate to measure reducing sugars. This ensures the final product has the right sweetness and texture.
Now we will see the advantages of a titration technique in food manufacturing. First is accuracy and precision. Titration allows for precise measurement of substances in a sample, such as acidity, pH, or the concentration of specific components like acids, bases, or salts. This accuracy is crucial for ensuring consistency in food products. Second is quality control. Titration is essential for quality control processes, food manufacturing, by monitoring and adjusting key parameters, for example, pH levels. Manufacturers can ensure products meet regulator standards and consumer expectations. Next is real-time monitoring. In some cases, titration can be performed in real time or near real time, allowing for immediate adjustments during production processes to maintain the product consistency. And lastly, compliance and safety. Titration methods are often recognized and validated by regulatory bodies, ensuring compliance with food safety and standard regulations.
Conclusion: titration in food manufacturing accurately measures specific acidity, alkalinity, salt content, and nutrient levels in products. These measurements maintains consistent quality, meeting regulations and ensuring safety. Food manufacturers use titration to adjust formulations for taste, texture, and nutrition, as well as to control shelf life and stability. Titration data guides decisions to produce safe, high-quality products that meet industry standards and consumer expectations.
This is our list of reference to make this video.